All right, chapter 5 here. These are the problems as promised. And we'll go through four problems, two with present value, two with future value, and we'll see exactly what the variations are and how do we compute for each. All right, the first one is simple. It says, what is the future value of 11,600 invested for 17 years at 7.25% compounded annually? Remember, I said those keywords are very important. Annually, what are we looking for? We're looking for the future value of what the present value is. This invested for 17 years at 7.25%. So automatically, we're looking for what? We're looking for the future value. What is your N? Your N is 17 years. What is your interest? Your I is 7.25%. And we're looking for the future value of what? The present value, which is 11.600%. So let's write out the formula. All right, we have a present value of 11,600 bucks times 1 plus your I, which is your 7.25%, compounded annually for 17 years. So it is 17 times 1 compounded annually, meaning that you get paid once a year. And if you compute that formula or these numbers here, you will get 38,125.30. So if you invest $11,600 today in an account that pays you 7.25% annually for 17 years, at the end of 17 years, you'll receive $38,125.30. All right, as easy as that. Now, if the example had said that you're getting paid semi-annually, therefore it would be 17 times 2. If the example had said you're getting paid, sorry, I don't know what that is. If the example had said you're getting paid semi-annually, it would be times 2. If the example had said you're getting paid quarterly, it would be 17 times 4. So be very mindful of the indicators of that compounding factor. So here you're getting paid annually, therefore it's 17 times 1. All right, next example. All right, it says today, right? Today. Automatically, I don't even have to read the rest of the problem. Today, that's present value. You earn a salary of 28,000. So today, your salary, your present value of the salary is 28,000. What will be, right? Keywords, what will be. So you're looking for what? The future value. What will be your annual salary 12 years from now? 12 years, that's your N. From now, if you earn annual raises, 2% annual, right? Your N is 1 times 1, right? It's N times 1. Raises of 2%, right? 2%. So you receive 2.6% on a yearly basis. So right now you're looking again for the future value, right? It tells you that your PV times 1 plus your I over your N times 1 annually will tell you what the future value will be. Again, your present value is $28,000. All right, big money here, right? $28,000 times 1 plus 0.026 to what? What will it be 12 years from now? 12 times 1 because you're getting paid annually. And if you compute that, you will get $38,100.12. Okay, let me just do this math really quickly to make sure we have the right amount. So it's 1.026 to the 12th power equals, all right, times 28, 1, 2, 3,000, and the answer is 38,112 cents. So if you're getting paid $28,000 and you're getting a raise of 2.6% in 12 years, you will get a big raise and you will be making $38,112. Okay. All right. Next example, present value. Your father invested a lump sum 33 years ago at 4.25% interest. Today, he gave you the proceeds of that investment, which totaled $51,000. How much did your father originally, right, in the present at that time, how much did he put in the investment to give you that future value of $51,000? 33 years ago, all right, and at 4.25%. So this is what we'll do to understand this question. Okay, we'll draw a little line. Okay, so this line represents 33 years of period that passed. All right, after 33 years, your father has $51,480.79 in his account. How much did he invest in time zero, which will be the present or the past value, PV, right? How much did he invest in time zero, right? At what interest rate? At 4.25%, right? To receive that amount of money, how much money did he invest in that time, right? So it says that your present value is simply your future value over 1 plus r, or I to the n power. Simply $51,480.79 was invested, or is the proceed on this account to 33 years from the day he put in the original amount, right? Over 1 plus, what's the interest rate? 4.25%. And how many time, what's the period? It's 33 years, right? 33 years. Do we have any indicators here? You're invested in also 33 years ago at 4%. Today he gave you the proceeds. Look, originally, how much did your father invest? All right, so if you don't get any indicators as to how many period, you're assuming that the payment was done annually, right? So if you compute that, the present value is simply the future value over 1 plus your interest rate to the n power. If you compute that, your father put in 13,035.75. All right, so at time zero, right here, your grandfather put in, or your father put in $13,035.75 into an account that paid 4.25% in interest for 35 years. That's the reason why in year 33, he has now $51,480.79 in his account. And most of these problems, the way you're understanding is by drawing a line diagram, right? And putting the amounts on the line diagram in order to know exactly what you have to compute. Is it the present value or is it the future value? Next problem. You would like to give your daughter $75,000 towards her college education 17 years from now. Okay, so now is the start. 17 years is the future. How much money would you like to give your daughter? You would like to give her $75,000, right? Towards her college education. Your n will be 17 years, so this line represents 17 years. Okay, how much money must you set aside today, right? How much would you set aside today, which is your present value, key indicator, today, present value. You would like to give your daughter 17 years from now, so this is your future value. This is your n, right? And this is your I. Simple, right? You're earning 8% on a yearly basis for 17 years, and you're trying to find out how much money should you put in the account today. As simple as that. So really, you're looking for the present value, and the present value formula is simply your future value, 75,000, over 1 plus I to the n power, which is 17 years times 1, right? 17 years times 1. If you compute that, this is 8% here, sorry. And if you compute that today, you have to put $20,270.17 in an account today, right here, in an account today, in order, that's earning 8%, in order to be able to give her $75,000 in 17 years. And as easy as that, while you're reading the problem, you can pick the keywords and write the letters next to them. That way it's very easy for you to compute, right? Very easy. As I mentioned in my previous video, slide 33, chapter 5, table 5.4 is the most important table for this whole chapter. If you can write that table down in your formula sheet, you'll be able to compute all the future value, present value for all the problems that will be related to chapter 5. All right. As I always say, if you have any questions or concerns, please send me an email through Canvas. Myself or my associate will be able to answer all your questions. We're here for that. Remember that your assignments are due on Thursdays and your quizzes are due on Saturdays. Thank you very much and have a wonderful one.